Welcome to the chromatography marking exam video. So first question, we have a chromatography setup here that is incorrect and you are asked to spot the two mistakes. Now whenever you're reading through this, you should first of all look very carefully for any clues in the image, and you'll notice two things stand out straight away that I have highlighted here. So the first mistake is the start line is below the solvent level. So the start line is here and the solvent level is up here. That's a problem because the samples of ink would wash off. So instead of traveling up with the solvent, they would simply wash off into the solution and you would have a big mess inside. So that's a bad mistake to be making. The second mistake is the start line is drawn in ink. Of course, ink might be a mixture. It will also be a problem because the line would also run. Another way of saying that is it will interfere with the results. So those are the two mistakes. 1B. It asks you to look at this chromatogram once it was done without mistakes. Remember, the solvent front here is labelled how far the solvent moved. You're asked what the colours are in the black ink. Now remember, whenever you see a chromatogram, this is what you should think. This is a mixture. These are pure substances because there's one spot here, one spot here, one spot here. Those are each one substance, pure. This is a mixture because there are more than one dots, suggesting that they were a mixture when they were together here. So all you do is you follow along and you think, where does this match up to? Well, the black ink contains this thing here, which is red ink, and it contains this thing here, which is blue ink. Which is the most soluble? Well, remember, the most soluble things will travel furthest along the solvent front. Sorry, will travel furthest along the solvent. Therefore, the one that moved highest was the yellow ink because it is most soluble. The thing that's furthest down is the least soluble, so we can label this as being the least soluble, and it is most attracted to the paper. This is least attracted to the paper. This is most soluble. In fact, let's label those as well. So this is the most soluble and it is the least attracted to the paper. Whereas this is the opposite. It's the least soluble and the most attracted to the paper. Or the stationary phase. Next question asks you to calculate the RF value for the red ink. Now remember, to find out the RF value, you need to get your ruler and you need to measure, first of all, how far along the red ink moved. And in this case, we know it's 13 millimeters. And how far did the solvent move altogether? And that is, it moved a total of 43 millimeters. And then you always do the smaller number divided by the bigger number so that your number is always less than 1. 13 divided by 43 gives you 0.30 to two significant figures, which is what you are asked to do. Now they will accept one either way on your measurements. If you put 12 or 14 millimeters, 42 or 44 millimeters here is fine. Remember, there are no units because we did millimeters divided by millimeters, so the units cancel out to give you nothing. How can we tell that blue ink's RF value is greater than red? Well, the higher up something is, so let's get blue, this is higher up than red, so it will be a bigger number divided by 43, so the fraction will be bigger and therefore the number will be bigger as well. So blue ink is higher up, so we know it is it's near the top of the paper, so we know it will have a greater RF value. Question 2 is about food colouring. We know it's a mixture, which is what the questions are asking, because in the same vertical line, remember vertical goes from bottom to the top along this way, there's more than one dot in a vertical line. If there was just one dot, then we know it's a pure substance, but because there's more than one, we know that it is a mixture that has separated. 1C, you're asked to plan an experiment. Now, the best thing to do when you're planning an experiment is to use the numbered step-by-step method. So you've got 1, 2, 3 numbered steps, etc., etc. So here's the simplest method. I'm going to put these up there for you to look at. So firstly, you draw a pencil line using a ruler near the bottom of the chromatography paper. So just very roughly, imagine I have my chromatography paper here. I'm going to follow this method step by step and see if it makes sense. So first you draw a pencil line. Let's imagine that I am using a pencil here. So I'm going to draw a pencil line with a ruler. I'm not going to use pencil now because it won't come out really clearly. So that's my pencil line. Put dots of known colours on the pencil line, leaving gaps between the dots. So I'm going to put a red, I'm going to leave a gap, I'm going to put a green, and then I'm going to put my unknown colour here, equally spaced out, which is the next step. Place the chromatography paper in a beaker with water that is below the pencil line. So I'm going to put this in a beaker, and the water will be below the pencil line. That's my pencil line. My solvent is now below, so that's good. Leave for the solvent to rise up through the paper, so I'm going to wait for my solvent to rise up. When the solvent reaches near the top of the paper, so when it reaches about here, let's say, I'm going to remove it and leave it to dry. So then I'm going to take this out and I'm going to leave it to dry. Compare the position of dots for known colours with those of the mixture or the ink that is unknown. So I'm going to look at to see, let's say they've separated out, and let's say I have red has moved up here, and I have my green has moved up here, and when I look at my blue, let's say it looks like this. I can compare my chromatogram and say, so my ink that was here contains green, contains red, and it contains something that I'm not sure about. That could be my conclusion. So notice how my step is so clear that it allows me to produce a method that works and produces really good results. So whenever you write a method, ask yourself, can someone follow your method word for word and get valid results? In this case, the answer is yes, so I would get 6 marks. Next question is asking you to explain how chromatography separates substances. So how does chromatography work, essentially? Well, the way it works is the mobile phase moves through the paper, so that's the solvent here, and carries different substances different distances. Okay, so the substances are carried differently. Why is that? The distances travelled by each substance depends on 2 things: their attraction to the paper, the stationary phase, and their solubility in the solvent, or the mobile phase. You need to learn and remember this because this applies to any type of paper chromatography. Next question is asked to analyze the chromatogram and describe and explain the results. So in my answer here, I've labeled anything I've described with a D and explained with an E. So there's loads of conclusions you can make as long as you have 2 with 2 descriptions and 2 explanations. You'll get 4 marks. So first thing I'm going to describe is by saying that let me just zoom out here, is by saying black ink is a mixture. I know it's a mixture because, what's my explanation? The ink separated into more than 1 dot. In fact, I've got 4 dots by the end. Next, black ink contains blue, red, yellow, and I know that because the RF positions of the inks match those in black ink. So this matches, so we can't see that. This matches because it's along the same line. So we've got the blue ink here, then we've got the red ink matches, and we've got the final color, which is yellow matches. So we know it contains those 3. There's my description and my explanation. Then it does not contain green. I know that because green is not present. There's no dot with the RF value of green. Another description I can have is that we know it contains an unknown ink color here, because there's no match, there's no matching ink with that one. And we know that that unknown color is insoluble because it does not travel. So loads of describes and loads of explain to match my descriptions. Final questions of this video link to, again, more practice identifying the different substances. But first it's asking what the mobile phase is. We're told what the solvent is. So remember, the mobile phase is the solvent, which is propanone in this case. Stationary phase in paper chromatography is, surprisingly, paper. Finally, what does figure 1 tell you about the green pigment from spinach? So the green pigment for spinach, what do we know about it? Again, loads of conclusions we can make. We know that it contains, let's use our rulers to see, it contains this one here, which is chlorophyll A. It contains carotene here as well, and it also contains chlorophyll B. It also contains this unknown substance here, which we call pigment B. So I've written here contains chlorophyll A, carotene, chlorophyll B, and pigment B, as well as an unknown substance that does not dissolve in propanone. Look, if it doesn't move, in fact, let's write this down. If a substance does not travel up the chromatography paper, it is insoluble. And the final conclusion you can make is it contains 3 substances. So you get a mark for identifying what's there, you get a mark for saying that there's an unknown substance, you get a mark for saying that it does not dissolve, and you get a mark for saying that it contains 5 substances. Once you've done that, you can add up your total out of 30 and put it at the front over here. Write that in.